All right, let's go ahead and look at another example. So the same setup. We've got two lines. One of the lines going through -1, 3 and 1, -1, and the other line is going through so -1, 3 and 1, -1. The other line is going through -2, 5 and 4, -7. We're trying to figure out if they're parallel, perpendicular, or neither. So same approach. We're going to determine the slope of each line. So if we plug in -1, 3 and 1, -1 into our slope equation, it's going to give us -1, -3. So -1, -3, that's this guy, take away 3, and 1 minus -1. And so that's going to simplify. -1 minus 3 is -4. 1 minus -1 is 2. And so that's going to be -2. And for M2, we'll do the same calculation. -7 minus 5 and 4 minus -2. -7 minus 5 is -12. 4 take away -2 is 6. And -12 over 6 is equal to -2. And so we can see from this that they are in fact the same. So M1 equals M2. So they're parallel, right? Well, not necessarily. The points I gave you, they could be on the same line. So it could be the case that here's, -1, -1, 3, right? And this one is, oops, that's not a very good picture for our graph. Let's go ahead and change the slope is negative, right? -2 is our slope. So, so here's our line. And so we could have, this could be -1, 3, and this could be 1 minus 1, and maybe 4, 7 is down here, or 4, -7 is down here on the same line. So we should determine, is 4, -7 on the same line, or is it on its own line? Okay, so let's check if they're the same line or if they're distinct. So let's determine the equation of one of our lines. So we know the point slope equation looks like this. Y is equal to mx minus x1 plus y1. And so we can pick one of our points. So for the red line, if we choose this point, -1, 3, then we're going to plug -1 in here and 3 in here, and -2 is our slope, so that goes in there. So that's going to give us y equals -2, x minus -1, so x plus 1, and then plus 3. So there's our equation for the red line. So to see if, in fact, these are the same line or distinct lines, we're going to take one of our 2 points of the other line, so either this one or this one, doesn't matter, and plug it in to see if it satisfies this equation. So in this case, I'm going to plug in this point, but you could also plug in 4 minus 7. So what do I mean by plug in? Well, this 5 is going to go in for y, and this -2 is going to go in for x. And so that's going to give us this equation. And we need to see if this is actually an equality, and if it's an equality, then that means that point's on the line. So 5 equals, let's go ahead and distribute. Let me erase this guy right here. So we distribute this, or combine -2 and +1, that's going to give us -1. And then multiply -2 by -1, that's going to give us 2. And so this is 2 plus 3 is equal to 5, and so 5 is equal to 5. And so that means that yes, -2, 5 is on the red line. Y equals -2, x plus 1 plus 3, whoops, go away, plus 3. Everything got a little bit dimmer. Oh well. And so that they are, in fact, talking about the same line. So it's not parallel, not perpendicular, they're the same line. And let's go ahead and look at a Desmos app. Uh-oh. This is going to take me out of my... Let's go back into here. Desmos app. There we go. And you can see that these 4 points are all actually on the same line. And so they're not parallel, they're not perpendicular, it's neither.